Hello friends, welcome to another lecture of Vector Calculus, lecture number 6, Mathematical Physics. And for MSc and BSc students, topics we are going to discuss here, scalar field and vector field. And links of the previous lectures are given in the description box. If you want, you can watch. If you want to watch them, you can go through them. Okay. Then before we start, please subscribe the channel and hit the thumbs up button. Also press the bell icon so that you get notified when new video is uploaded. Okay, so now what do you mean by scalar field? Suppose let us consider a region. Okay, let us suppose to each point xyz in the region D. Suppose let me assign the region as by the letter D in space. Then there corresponds a number, so any number, so that is a scalar, that means a number that is given by phi, which is a function of xyz. That means this is a function which gives the number associated with that particular coordinate xyz, right? Let us consider this phi is a function which gives the scalar quantity or number which is associated with this coordinate. Then this phi is said to be scalar function of position, or we can say that scalar field phi has been defined on the region D, right? Suppose this is the 3D coordinate system and xyz, this is the origin O, and we have taken a region. This region is suppose D in 3D space, so these are different points. So this is a particular point, its coordinate is xyz, and the scalar quantity associated with is given by suppose c1, which is given by this function. This function can give the scalar quantity associated with this particular coordinate. Then suppose we have taken another function. Suppose here the scalar value, the number or scalar quantity which is associated with this particular point is suppose c2, and this is given by phi. Suppose this function phi, its coordinate suppose x dash, y dash, z dash. So if you put these values here in this function x dash, y dash, z dash, then it gives this c2 which is associated with this particular coordinate. So then in this case this phi is said to be a scalar function of position, right? And we can say this a scalar field phi has been defined on this region D, right? For example, you can see the temperature is a scalar quantity, right? Temperature at any point within or on the surface of the earth, at any time is also a scalar field, scalar field. So hope you have understood what is a scalar field. And remember, if the scalar field is independent of time, then it is said to be steady or steady state field, or stationary or steady state scalar field, you can say that, right? Now let us discuss about vector field. What do you mean by vector field? So let's move on to next slide, vector field. So similarly here also you can see, suppose let us suppose to each point of a region, suppose to each point xyz in a region D in space, there corresponds suppose vector quantity v x y z. Okay, a vector quantity is associated with this coordinate xyz in that region, right? Then v is called vector function of position, and we can say that vector field v is has been defined on the region D. So hope you have got this. That means let me explain. Here you can see this is the 3D coordinate system. Suppose in a certain region we have taken different points here xyz, and its corresponding vector quantity is suppose v x y z. Okay, it gives the vector quantity at this point, at this particular point, right? uh, at this particular point, what will be the vector quantity that is given by this function v. So it may be electric field, it may be magnetic field. Okay, these are vector quantities, right? So if you keep a charge here at the origin, suppose let me keep a charge here, positive q, then due to this charge, so let me keep let us suppose I have kept a charge here, kept a charge that is q positive. Due to this charge, there must be electric field at this point, right? So the strength of magnetic this electric field and intensity of electric field at different point will be different, right? So that is suppose given by this function, then this function is said to be uh, you know we can say this is a function of position, and we can say this vector field v has been defined in the region D, right? So at this point, suppose this point is given by x dash y dash z dash, so its corresponding vector quantity is given by suppose v dash x dash v of x dash y dash z dash. This gives the corresponding vector quantity associated with this point. Then v is said to be the scalar field on this region D, right? And let me take in another example. Suppose in a fluid, if you find the velocity at any point, then that's going to be also a vector field. Suppose this is the water flowing in the river, and at a particular point you have calculated the velocity at a certain time. The velocity at any point within a moving fluid at a certain time is a vector field, right? And similarly, a vector field which is independent of time is said to be stationary or steady state vector field, right? So hope you have understood what is vector field and what is scalar field. So if you have understood and if you like the video, just hit the thumbs up button and share with your friends. And if you're new to my channel, please subscribe the channel and inspire me to create new contents for you. And hope it is helpful, and see you in the next video. Thank you for watching.